Have you wondered why wind turbines seem to always have 3 blades? You and I have an insatiable appetite for electricity. Come with me and we'll look at the issues relative to wind farms and the communities that they serve. This is the Windfarm Guy. Hi, this is Dennis Stout, and thank you for joining me for this episode of the Windfarm Guy. Have you ever wondered why wind turbines have 3 blades and not more? Well, there's a scientific reason for why that magic number is 3. Wind power has been a reality for humans for centuries. From sailboats to windmills, the energy in wind has been tapped through much of human history. In recent years, wind power has gained greater awareness and popularity through the use of wind turbines to generate electricity as a productive, sustainable alternative to fossil fuels. Today, wind farms dot Earth's coastlines, mountaintops, and open prairies. You've probably noticed something common among them. They all have 3 blades. No more, no less. Not 2 blades and not 4 blades, but 3 blades. 3 is the number of blades a wind turbine has. All you Monty Python fans will get that loose reference. Anyway, why do wind turbines have 3 blades as opposed to fewer or more? Well, the answer lies in the engineering behind wind power and how to maximize the yields from that energy. In order to produce the highest amounts of electricity efficiently, there is a lot to take into account. Let's back up. Electricity generating wind turbines are older than most people think. The first such turbine was invented in 1888. Amazingly, it had 144 wooden blades and generated 12 kilowatts of power. I bet that was a sight. After many iterations and refinements, small turbines known as wind chargers were produced and were the only source of electrical power for many rural Americans up until the mid-1930s. Wind turbines were an accessible, cost-effective way to power remote locations that were not otherwise being served by main power lines. After the expansion of the power grid throughout the United States, rural wind turbines effectively died off, and windmills to pull water out of the ground were the only thing using wind power. It's only in recent years, just a few decades actually, that there's been a resurgence in interest in wind power as a cheap alternative to other forms of electricity production. The principles behind the conversion of wind energy are as simple today as they were in the 19th century. Wind has kinetic energy that wind turbines attempt to capture and convert into electricity. Converting the energy is a simple process. Doing it efficiently, well, rather productively, is another matter altogether. The design and utilization of the turbine blades is a fine science with many nuances. The physics behind the design have a lot to do with aerodynamics and air resistance. Aerodynamics refers to the properties of a solid object and how the air around it interacts with it. That is why wind turbine blades closely resemble airplane wings, propellers, and helicopter rotors. They are all airfoils. The blades have specifically designed curves, twists, varying surface areas, and different angles of attack. This varied shape causes a pressure differential when the air moves across the surface of the blade, which is what causes the blade to move. Because of the obstruction of the blade, air moves at a faster velocity behind the blade than in front of it. In an airplane, the wind is faster above the wing than below it. This is called lift. But in a wind turbine, it sets the rotation of the blades in motion. Thus begins the first conversion, that of converting the kinetic energy in the wind to the mechanical energy in the shaft attached to the rotor, which the turbine ultimately converts into electrical energy in the generator. However, it is not enough for the blades to be moved by the wind. Like an airplane, engineers must consider speed and drag in designing turbine blades to ensure the highest level of efficiency. Turbines are designed to have optimal output at an optimal number of RPMs. More importantly, the tip speed of the blades. You wouldn't want them going too fast. Okay, what about the number of blades? Well, the decision to design turbines with 3 blades was actually somewhat of a compromise. Because of the decreased drag, 1 blade would be the optimum when it comes to energy output. However, 1 blade would not be balanced at all, and therefore not practical for stability of the turbine. Similarly, 2 blades would yield more energy than 3 blades, but would come with its own issues. 2-blade wind turbines are more prone to a phenomenon known as gyroscopic precession, resulting in wobbling, bad wobbling. Obviously, wobbling would compromise the stability of the turbine and cause far more wear and tear on the internal workings of the turbine, which would shorten the life and efficiency of those components. Any number of blades greater than that would just create greater wind resistance, which would slow the generation of electricity. So 3 is the number. More than 3 blades would not add to the turbine, it actually would make it less productive. And there you have it. It just makes sense for the turbines to have 3 blades. If you like what I've said today, be sure and click like and subscribe below. If you have thoughts on or want me to address a particular topic relative to wind farms, please leave me a comment. For now, wind turbines pretty much all have a horizontal axis and 3 blades. That's the most productive configuration modern engineering has developed. But that might not always be the case. Currently being developed are bladeless turbines. That's right, wind turbines without blades. Wouldn't that be great? But until those are fully developed into utility scale machines, these 3-blade wind turbines will be the norm. This is Dennis Stout, and I'm the Windfarm Guy. Thank you for watching. Working together, we can make good energy decisions and save our planet. I am the Windfarm Guy.